In this video, we're going to take a look at double displacement reactions. We'll be able to identify them and also predict products of double displacement reactions. There are several types. There are those that produce gases, those that produce precipitates, and then also some that are neutralization types. Oftentimes, the gas ones are just a special type of neutralization as well. So as usual, please make sure you watch the preview video with some great examples and sample problems done for you, as well as some great real-world applications. So you can watch this before you watch the entire video. So let's take a quick look at what a double displacement reaction is, just at the general level that you would have seen in grade 10. We have two compounds reacting. Usually this happens in an aqueous solution where the ions are free to move around in the water and they can interact with each other. So we have a compound AB reacting with compound CD, and essentially the partners switch spots. So A will go with D in the end, and C will go with B. In a single displacement, there was always something left alone and a new compound. Here you have two new compounds that form. Basically two things. Nothing is lonely. Nothing is left alone. So one example we're going to take a look at is a double displacement reaction that produces a gas. This type of double displacement reaction happens in two steps. There's, first of all, the double displacement. So here we have HI plus Na2CO3. And they're going to switch spots. So the H will switch spots with the Na, and the Na will go with the I now, so NaI. And then we get H with the carbonate, which is H2CO3. Now, once the H2CO3 is produced, this is going to break down into the water and carbon dioxide that you see there. And so this is the gas that's produced. You'd see bubbling that is produced as a result of that. In fact, a very simple reaction of this that you would have seen is baking soda reacting with vinegar. When that happens, you have a reaction that happens like this, and then you have the H2CO3 that's produced break down to water and carbon dioxide. And this, in a sense, is a type of neutralization reaction as well, because this is the acid and this is the base. So remember, we said that bases don't always have to have hydroxide. They can sometimes be carbonate type compounds, like a metal carbonate type compound, for example. So when you're doing an example like this, you need to make sure you show both steps. First, the double displacement, and then if you see H2CO3 or one of these compounds here, then you know they're going to break down. So if you get the production of NH4SO3, that breaks down to, H2SO3, that breaks down to H2O and SO2. If you get NH4, here I meant to put NO3. Let's go fix that before we forget. So this is NH4NO3. There you go. That will break down to form some water and some ammonia, and that's the gas that's produced there. And if you see H2CO3, as we saw, that's water and carbon dioxide. So you can see that it's water every single time, liquid, and then the gas is what's different for each one of these. And so that will result in this one here in particular. You'll smell a strong odor, which is the ammonia odor. So we'll take a look at do some examples of that. Before we do that, I want you to watch this demonstration and write down an equation for the reaction that's being described. Classify the reaction based on the type, so is it single, double, synthesis, decomposition, so on and so forth, and then list the evidences that a chemical reaction actually occurred. So do watch the video. It's a really, really cool demo, and you'll get the joke if you actually watch that video. So let's go do some examples where we have a gas being produced in the process. So the handout for this is right over here. Before I make a PDF version, I just want to, okay, perfect, it's corrected there, so we got that corrected. All you have to do is follow along and fill in some blanks and do some practice problems with me. And you're more than welcome to try some of these problems first, pause the video, and then check your work after. So here we have double displacement reactions. This is the general equation for them. And let's go ahead and try the first one, which you've already seen. So the cation switch spots. So the H will go with the CO3 and the Na will go with the I. So that'll make NaI, and that'll be aqueous. And we're going to also get H2CO3. And that's aqueous. And the reason we get H2CO3 is because the H goes with the carbonate. And so that's going to be H plus 1, carbonate, which is -2, and we crisscross it. And that's going to be aqueous as well. And our second part is now just rewriting this equation NaIAQ plus replace these by this one here by water, which is what it breaks down to, and CO2, gas. And so you would see bubbling that results from that, and that comes from the decomposition of the H2CO3. And like I said, there's other compounds that decompose. These are the compounds here that decompose, and you do need to recognize those when you're doing a double displacement. So let's try another example here. We have NH4Cl, solid, reacting with barium hydroxide, solid. Now I know I said most times these happen in aqueous solutions, but you can have some exceptions where you have the reaction happen as solids as well. So let's do part one over here. We're going to do our switching. So our cations are going to switch spots. NH4 and Ba will switch spots. So NH4 will go with the OH and Ba will go with the Cl. So we will get BaCl2 plus we're going to get NH4OH. So NH4OH. This here will be aqueous, and so will this. And now what we need to do is we need to rewrite this as BaCl2 aqueous plus we're going to decompose this one here into NH3, as we can see over here, which is our gas, plus H2O, which is our liquid. And so this came from here and here. So we had a double displacement and then our decomposition. And so that's a specific type of double displacement reaction where you have one of these compounds produced and it results in a gas being formed. So in this example here, we saw that this was an example of a neutralization reaction, but it resulted in a gas being formed. And then you can take a look at other examples here. This also will actually be a neutralization reaction as well, just not in the traditional sense that you're used to seeing. But for example, this part here acts slightly acidic, and this part here is the base. And you'll notice that with the OH there and the OH there. And here you'll notice this is a base with the carbonate there. And so in the next video, what we're going to do is we're going to take a look at some reactions that involve precipitates forming instead. And we're going to see how we can identify if we have something soluble or insoluble in our reaction. So for now, you can practice double displacements with gases. In the next video, we're going to take a look at double displacements with precipitates.